All right, let's just jump right in. Think about almost every piece of technology you use every single day. Behind all of it, there's this tiny, powerful, and pretty much invisible engine, the semiconductor. Today, we're going to break down how this one single invention is literally reshaping our world from the ground up.
You know, it wasn't that long ago that semiconductors were just for basic math and storage, like in old school computers and calculators. But they've come a long way since then. Now, they're the key to actually augmenting our own senses, merging our physical world with the digital one. It's getting to a point where the line between human and machine is getting seriously blurry.
Okay, so first up, let's talk computing. And this isn't just about making our gadgets faster. This is about how semiconductors built an entirely new reality that paved the way for the age of AI.
I mean, just look at this. It's one of the greatest shrinking acts in history, right? We went from computers that took up an entire room to the smartphone that's sitting in your pocket right now. And that whole incredible journey was made possible by one simple idea: making semiconductors smaller and smaller.
But here's where the plot thickens. For decades, the rule of the game was simple: shrink the transistors to make them faster. The problem is, we're pretty much at the end of that road. We're hitting the fundamental physical limits of how small things can get. I mean, we are literally running out of atoms to work with.
So if you can't go smaller, what do? Well, the industry had to come up with a whole new playbook. It's called advanced packaging. And the big idea here is, instead of just trying to shrink one chip, you get smarter about connecting multiple chips together. Think of it less like trying to create one superhero and more like building the Avengers, a whole team of chips working together to boost performance.
And this is what that solution looks like in action. You have technologies like high bandwidth memory, or HBM, which are stacked vertically, almost like a skyscraper for data. It's all connected with that advanced packaging, creating this massive superhighway for information. This is what gives us the huge jump in processing speed that's absolutely essential for the kind of AI we have today.
Okay, so that's how this tech thinks. But what about how we see it? Well, semiconductors have also totally transformed how we visualize information, basically remaking our reality through the evolution of displays.
For years, we all had LCD screens, and they were kind of complicated. They needed a big backlight shining through a bunch of layers. But then OLED came along and changed everything. With OLED, every single pixel lights itself up. That much simpler design means we get screens that are way thinner, flexible even, with colors that just pop and blacks that are truly black.
And if you want to know where this is all headed, you just have to wrap your head around this phrase: pixels smaller than a gnat's eye. That's the kind of mind-boggling precision we're talking about for the next generation of displays. And it's a feat that's only possible because of advanced semiconductor tech.
So why do we need that kind of insane precision? For this, the expanded reality, or XR, revolution. If you want to create virtual experiences that feel completely real, or overlay digital information onto the real world seamlessly, you need displays that are unbelievably dense and high resolution. Semiconductors are the engine making it all happen.
And there are two key technologies driving this right now. You've got micro OLED, which gives you that crazy high resolution you need for a smooth VR experience. Then, on the other hand, you have micro LED. It's super bright and really efficient, which makes it perfect for augmented reality glasses that you can actually use outside in the bright sun.
So we've seen how they compute and how they help us see, but the semiconductor revolution, it's also on the move. And I mean that literally. It's turned our cars from just mechanical machines into what are basically smartphones on wheels.
Think about it. A car used to be all about mechanical engineering. Today, it's a rolling, high-tech computer. And yeah, semiconductors are the brains behind everything from the engine to your infotainment screen. But the real game changer is how they're making autonomous driving a real possibility.
So what's actually under the hood of a smart car? Well, you've got a high-performance AI chip that acts as the brain. You've got LiDAR and radar sensors that are like the car's eyes, seeing everything around it. Then you have cameras and ultrasonic sensors for perception up close. And crucially, you've got power semiconductors managing all the energy, and even smart headlights that can adapt to conditions on the fly. It's this whole team of tech working together.
Okay, so let's try to bring all these different pieces together now. We've seen semiconductors in our computers, in our screens, and in our cars. The final frontier? Well, it's embedding them into everything else, creating a totally hyper-connected world through the Internet of Things.
The Internet of Things, or IoT, is really just the idea that everyday objects, from your fridge to a robot in a factory, can have a chip inside that connects them to the Internet. Semiconductors are the heart of all this, giving digital intelligence to the physical world around us,
which makes our lives more convenient and our industries way more productive.
And this isn't science fiction, it's already here. In a smart home, your devices are learning your patterns to make your life easier. Your smartwatch is monitoring your health in real time. And in smart factories, you have unmanned operations running 24/7. And the invisible engine making it all possible? Yep, tiny little semiconductors.
So when you pull it all together, the big picture becomes super clear. Semiconductors are the fundamental engine of all modern innovation. They let us process information with AI, visualize it with next-gen displays, and act on it with things like self-driving cars. They really do connect every single part of our modern lives.
And that brings us to the final and most important question. We've already seen how this technology has completely reshaped our world in ways that were once unimaginable. So as these chips become more and more integrated into the very fabric of our lives, you just have to wonder, what's next? What new realities are we going to build with them?